This is the final exam review for Math 1630 Finite Mathematics in spring of 2016. And we are going to work the part of the problems that we have here that don't require me to actually show you the calculator keystrokes. Those will be completed in a separate recording so that I can have both the calculator and the answers on the same screen. So we'll begin with problem number 1, which is a substitution problem. It says the number of new motor vehicles in millions, and that's very important that we notice that this is in millions, that Canada produces can be found by f of x is equal to negative 0.083x plus 3.0, where x equals 0 corresponds to the year 2000. And our first question is, how many new motor vehicles will Canada produce in 2011? Well, 2011 corresponds to x equals 11. So in order to find the answer to that question, we're going to calculate f of 11, the value of this linear function at 11, which means we will substitute the number 11 in for x. And it turns out that that number is 2.087. But remember, it said that's in millions, and a million is 10 to the 6th power. So that actually turns out to be 2,087,000 vehicles. So in 2011, Canada produced 2,087,000 new motor vehicles. And in our next question, it says, assuming the linear trend continues, estimate when the number of vehicles produced will be 1.825 million, which means then in this case we're looking at where f of x is going to be 1.825. We don't count the millions because that's how f of x is measured, is in millions. So that means what we're looking for is when is negative 0.083x plus 3 equal to 1.825. And in order to solve that, the first thing we'll do is we will subtract 3 from both sides. And when we subtract 3 from both sides, we get negative 1.175 on the right-hand side. And still have the negative 0.083x on the left-hand side. And so in order to get rid of the negative 0.083, since it's multiplying, we will divide both sides by negative 0.083. And that leaves us with x is equal to 14.156. And remember, X represents the number of years after the year 2000. So that means that that year will be 2014. So in 2014, Canada will produce 1.825 million new vehicles. So we are now ready to move on to the second problem. And the second problem says that we're given the cost of producing X ink cartridges for a printer is given by C of X is equal to 24X plus 18,000. And the revenue is given by R of X is equal to 28 times X. And X, of course, represents how many ink cartridges. And we want to find the break-even point. And the break-even point is always where your cost, which is C of X, is equal to your revenue, which is R of X. So you're not making a profit, but you're not losing money at that point. So in order to answer this question, we're going to set C of X, which is 24,000, or excuse me, not 24,000, 24X plus 18,000. And that's going to be equal to 28X. And then in order to solve this for X, we will take 24X from both sides by subtraction. And that leaves 4X on the right side and the 18,000 alone on the left side. So then we know that our answer can be arrived at by dividing both sides by 4. And 18,000 divided by 4 is 4,500. I'm sorry, yes, 4,500, 4,500. So what that means is that you will break even the break-even value is 4,500 ink cartridges. For a cost of $1,260,000. Which is also the revenue. Because that's where cost and revenue amount is the same. So it says if the company sells exactly the number of cartridges needed to break even, what is its revenue? If they sell 4,500 cartridges, their revenue will be $1,260,000. Here we have problem number 3. It says, suppose the supply of and the demand for a certain textbook are given by these two functions, supply being P is equal to 1/5 of Q squared, and demand is P equals negative 1/5 of Q squared plus 20. P is the price and Q is the quantity of the textbook. And they want us to graph both functions on your calculator and tell where the equilibrium point is, what the equilibrium price is, and what is the equilibrium quantity. This is actually the same as question number 3 on the old final exam review. And you have the key to that one, so if you would like to see the graph and the information for that, you can look there. But you can also determine these, even though it says graph both the functions on your calculator. So even though we could graph the function on the calculator, we can find this algebraically as well. On the key, the graph looks something like this. And this would be your supply function. And this would be your demand function. And you know that because your demand function is a negative quadratic, so it's going to open downward, and your supply function is going to open upward because it's not negative, it's positive. So that's how you can easily tell which is which. This is going to be your equilibrium point right here. And the equilibrium point is actually at about 7.07. 10. And you find that using intersect after you've graphed both these functions. And I would suggest a viewing window that goes from 0 equal to or less than x equal to or less than probably about 15. And your y window needs to go from about -5 equal to or less than y equal to or less than, I'd say, about 10, so that you'll be able to see your intersection. Oh, actually not 10, probably better if you do 20, because this one is going to cross the y-axis at 20. But at any rate, there's your equilibrium point, and your equilibrium point in this case is 7.0710. Which you could also find by setting supply and demand equal to each other, which would be 1/2 Q squared is equal to negative 1/2 Q squared plus 20. And when you add 1/2 Q squared to both sides, you wind up with 1Q squared, or just simply Q squared, is equal to 20. And then that means that Q is equal to the square root of 20. And the square root of 20 is approximately 7.07. So, what is the equilibrium price? Well, the equilibrium price is the value P. So that's 7.07. And since that would be in dollars, that would be $7.07. The equilibrium quantity, on the other hand, would be the 10. So people are willing to supply, and there is a demand for 10 books. We'll call that 10 units of the textbook. Is where supply equals demand, and that's at the price of $7.07. Question number 4 is about matrices, and here again I would suggest that you check with the printed key that I gave you for the exam, because these are the same problems that are on problem number 4 for the practice exam. And you will find that G minus 2F on your calculator, you enter so here for DE, what we need to look at is matrix D and matrix E, and we see that matrix D is a 3 by 1. And matrix E is a 1 by 3. And since our inner dimensions match, that means that our product matrix is going to be a 3 by 3. So when we multiply D times E and we get the resulting matrix, it shouldn't be a great surprise that it actually does come out to be a 3 by 3 matrix, and that matrix is 6, 18, negative 24, 1, 3, negative 4, and then 0, 0, 0 on the bottom row. And similarly, matrix F times matrix G is going to result in a 2 by 2 matrix. And that matrix will be 0, 7, 19, 72. Matrix B times matrix C is going to be a 3 by 2. And that matrix is negative 9, negative 15, 7, 9, and 1531. Now we come across a problem with matrix AB. And the reason we have a problem with matrix AB is because matrix A is a 3 by 2. Whereas matrix B is a 3 by 3. So what we have here is a problem because our inner dimensions don't match. Therefore, we get a dimension mismatch, which tells us that matrix AB is not possible. And you would need to tell me not only that it's not possible, but tell me why. Show me why. And as we discussed before, there actually is no problem 5 On the other test, problem 5 is actually this problem, which is labeled 6. And they ask us to solve this system using matrices. So the way that we're going to do this system is we're going to make the coefficient matrix. It says using Gauss-Jordan. Well, you can use any method that you want to. I'm going to use the inverse method on these because it works. So matrix A is going to be 3, 1, negative 1, 1, 0, 2, negative 3, negative 1, 2. And matrix B is going to be the coefficient, the constant matrix. So it's going to be 3, 6, 9. And if I do then the inverse of A, that's A, and then use the x to the negative 1 to find its inverse, times B, I will get the solution matrix. And the solution matrix is negative 18, 69, and 12. So that means the solution to that system is the ordered triple, negative 18, 69, 12. And you can use that same method on the problem in B, or you can use the reduced row echelon form by forming the augmented matrix where you have 1, 1, excuse me, we don't want that 1 there, that would be the coefficient of y, so that will be 1, 0, 1, and negative 3. And then y means the coefficient of x is 0, coefficient of y is 1, the coefficient of z is negative 1, the constant is 6. And then the last one, the coefficient of x is 2, the coefficient of z is 3, the coefficient of y is 0 because it's not there, and the constant is 5. And if you do the reduced row echelon form of this matrix, where you've put this matrix in A, you will come out with this answer. So what that tells us is that the solution to this matrix is again the ordered triple, negative 14, 17, and 11. If you try doing the inverse method, which I did on A, and it doesn't work because it tells you that matrix A is a singular matrix, then come back and do the reduced row echelon form like I demonstrated in part B. In problem number 7, we're going to actually apply and solve the system. So that means that we are going to take this system of equations and form a 2 by 3 matrix of 3, negative 5, 16, 2, 3, negative 2. We're going to do the reduced row echelon form of that matrix, which we will have stored in matrix A or B or wherever. And when we get the resulting matrix will look like this. And what that means is that x is equal to 2 and y is equal to negative 2, or the ordered pair 2, negative 2, which is the solution. On this one, we are told to graph that system of inequalities. You can graph these with your calculator if you wish, just by graphing the related equations. 4x plus 2y is equal to 8, which means at y1 you could enter 8 minus 4x divided by 2. And what you will get then is a graph that looks kind of like this. And this says x is equal to or greater than 0, and y is equal to or greater than 0. So we're going to go with first quadrant. And the y-intercept of this first equation is going to be 4. And the x-intercept of that equation is going to be 2. And it has equal to in it, so it's going to be a solid line. And then we have 2x minus 2y is equal to or greater than 4. And you can graph that on your calculator. By starting out with the related equation. Or you can use the intercept method, because this one, the x and the y-intercept are both 2. Let's see, the y-intercept would actually be negative 2. And the x-intercept would be positive 2. So that would be this line. The red line will be the first one. And this simply tells us that it's quadrant 1. And then try plugging 0 into each inequality. So on the red inequality, 4 times 0 plus 2 times 0 is 0. Is 0 equal to or greater than 8? And the answer, of course, is no. So for the red equation, we're going to shade that direction. And then in the second equation, 2 times 0 minus 2 times 0 is still 0. Is 0 equal to or greater than 4? And again, the answer is no. So on the blue line, we will also shade away from the origin. So the place that we're actually going to be shading in the same direction is going to be below the blue line and above the red line. which gives us that feasible region. And that would be your answer. Problem number 9 is a little bit lengthy. It says a social services agency provides counseling, meals, shelter to clients referred by sources 1, 2, and 3. Clients from source 1 require an average of $100 for food, $250 for shelter, no counseling. So we're going to choose source 1 to be X. And the commodities that they will take in are food, shelter, and counseling. And the reason that we're choosing it that way is because we have multipliers for the units of those quantities. So for source number 1, their clients require 100 per client for food and 250 per client for shelter, but no counseling. So that would stay blank. And then source number 2's clients would be Y, and they require $100 for counseling and $200 for food, but nothing for shelter. And then we have source 3. And their clients, the number of their clients will be Z. And they require an average of $100 for counseling, so that's 100Z. And 150 for food, so that's 150Z. And 200 for shelter, so that's 200Z. And that'll complete our table. And the maximum amount of money they've got then is going to be given in this last set of constants. So they have at most $25,000 for counseling. They have at most $50,000 for food. And they have at most $32,500 for shelter. How many clients from each source can they serve? Well, this has given us the system of equations. And that system of equations is 100x plus 200y plus 150z is equal to or less than 50,000. 250x plus 200z is equal to or less than 32,500. And then 100y plus 100z is equal to or less than 25,000. And from that, we will get a matrix A, which will be the coefficients 100, 250, 0, 200, 0, 100, 150, 200, 100, and then our top maximum amounts, 50,000, 32,500, and 25,000. And when we do the reduced row echelon form of that matrix, we get 1, 0, 0, 50, 0, 1, 0, 150, and 0, 0, 1, 100. And now we need to interpret what that means. And that's part of your solution. So our solution is the agency can serve 50 clients from source 1, 150 clients from source 2, and 100 clients from source 3. Which answers the question. Always answer a question in a sentence. Problem number 11, we have a company that's making two kinds of pizzas, special and basic. So in this case, our two variables will be the special and the basic pizzas. So our basic will be, let's say, y.